exchanger, its temperature begins to rise gradually. The heating is even and controlled, with no boiling or agitation.
The milk reaches the target pasteurization temperature and is held at that temperature for a precise duration. During the holding phase, the milk continues flowing at a constant speed through the holding tube. There is no foaming, separation, or color change.
After the holding time is complete, the milk enters the cooling section of the heat exchanger. Cold water flows on the opposite side of the plates.
The milk temperature begins to drop steadily as it moves through the cooling zone. The cooling process is gradual and controlled to protect milk quality. The pasteurized milk flows into a clean stainless steel balance tank. The tank is designed to temporarily hold milk before the next production stage.
Sensors continuously monitor the temperature and volume of the pasteurized milk. Any deviation would trigger automatic system adjustments.
The flow rate on loop 3 is holding steady at 90 degrees.
Good, the batch integrity looks stable.
I've logged the temperature adjustment.
The pasteurized milk remains fully enclosed within the processing system, ensuring hygiene and consistency throughout the factory. Pipelines carrying pasteurized milk are clearly marked for cheddar cheese production only. No other dairy products are processed in this line. The stage concludes with pasteurized milk stored in holding tanks, fully prepared for the next step, adding starter cultures for cheddar cheese production.
Starter cultures specifically selected for cheddar cheese production are released into the milk. The culture
Flour at 50 kilograms. Noted. Sugar is next.
The milk inside the vat circulates smoothly, allowing the starter cultures to spread uniformly throughout the entire volume.
Check the consistency on this block.
Looks perfect. Proceed with transfer to the covered bin.
The agitator stops once distribution is complete. The milk returns to a still state, with a flat surface inside the vat.
Place the next one right here, carefully.
Got it. Making sure the spacing is perfect.
We're almost done with this batch.
The milk remains undisturbed during the incubation period. No additional ingredients are added at this stage.
bulk sugar, 50 kilograms confirmed. Labels match the manifest.
Sealed and sanitized. Sprinkles are clear. We are ready for the shift.
temperature readings on the main display.
They're holding steady at the target range.
Good, let's keep monitoring the flow rate.
The environment remains clean and controlled, with stainless steel pipes, valves, and platforms surrounding the vats.
Work. The process is slow.
No curd formation is visible yet. The milk remains fully liquid, confirming that rennet has not been added.
The incubation period proceeds for a specific duration based on cheddar cheese standards. All parameters remain within target ranges.
The milk is now fully inoculated with starter cultures and ready for the next stage of cheddar cheese production.
2 degrees Celsius, holding steady. Confirmed. Egg tank is at 4.
Yeah, I'll log that now. A little higher on the left.
Okay, is that straight now?
Yes.
Batch number 7492B, 25 kilograms.
Looks correct. Seal it up.
Did you get the cinnamon weighed yet? Almost done, just finishing this batch. The glaze is ready. Because of the vat's massive diameter, the rennet stream disperses gradually as it sinks into the milk.
The milk gradually transitions from a freely flowing liquid into a soft gel structure.
The curd mass pulls gently away from the inner walls of the vat, creating a visible separation line. This confirms full rennet action at industrial scale.
Did you see the latest reading on the centralized screen?
Yes, the coagulation time is right where it should be. The cutting frame begins descending slowly into the curd. Because of the enormous vat size,
Once the vertical cuts are complete, the gantry retracts and repositions itself for horizontal cutting. The movement.
A second cutting pass moves horizontally through the curd columns. The wires slice the columns into evenly sized curd.
The cutting frames lift upward, dripping whey straight down back into the vats. The motion is slow and controlled to avoid disturbing the curd structure.
The curd size is consistent across all 3 vats.
Okay, logging that now. The whey separation looks good.
The factory floor below remains dry and unobstructed, with industrial drainage channels built into the overhead lighting arrays illuminate the vats evenly, ensuring that curd size consistency can be visually verified across the full width of each container.
19. The whey level continues rising steadily as the curd cubes settle under their own weight. The curd pieces remain sharp-edged and well-defined, showing correct cutting.
Beneath each vat, a built-in heating jacket surrounds the lower section of the steel walls.
Warm water or steam begins circulating through the heating jackets. The temperature inside each vat starts to rise slowly and evenly across the entire curd mass.
The stirring action prevents curd cubes from sticking together while allowing whey to continue separating.
Check the whey separation near the center. Yeah.
Looks clear, we're ready for the next phase.
The curd cubes slowly shrink as moisture is expelled. Their edges become firmer and more defined, a key character.
The factory floor below the vats remains clear, with graded metal flooring and drainage channels designed to handle whey at high volume.
The vats now contain partially cooked curd cubes, surrounded by a higher volume of whey.
At the base of each vat, large stainless steel outlet valves are built directly into the structure. These valves are wide and reinforced to handle high-volume whey release.
The volume of whey released is immense, filling the channel rapidly. The flow remains smooth and controlled, without splashing back into the vat.
As whey continues draining, curd cubes settle closer together due to their weight.
The factory floor beneath the vats is designed specifically for this stage, with deep stainless steel troughs and grated.
As draining continues, the whey becomes clearer and lighter in color, while the curd appears more solid and compact.
The curd mass inside the vat no longer floats freely. Instead, it settles into a thick layer several feet deep.
The flow rate on vat 12 looks good. Agreed. Logging the data now.
Once the target whey level is reached, the outlet valves close gradually. The final streams of whey drip down into the collection channels.
Each cheddaring table is several meters wide and dozens of meters long, supported by heavy steel frames and surrounded by graded walkways.
Once arranged, the blocks rest flat on the table surface. Gravity causes additional whey to seep out, forming thin streams that run toward the drainage channels.
As cheddaring continues, blocks are stacked on top of one another. The stacks are aligned carefully.
The weight of the upper blocks presses down on the lower ones. This pressure forces additional whey out of the curd structure.
The curd texture begins to change visibly. The blocks become smoother, firmer, and slightly elastic as the cheddaring process progresses.
The alignment on table 12 looks off. I see it. The block size is inconsistent with the target specs.
After another interval, the stacked curd blocks are separated and rearranged again. Blocks are flipped and restacked in a repeated cycle.
Inside the enormous cheddar cheese factory hall, the cheddared curd blocks are no longer stacked on tables.
The strips continue forward into a secondary cutting section. Here, they are chopped further into smaller curd pieces, each piece roughly consistent in size.
As the curd move beneath the hoppers, salt begins falling in controlled streams. Grains descend vertically, and
the amount of salt is carefully regulated. The salt distribution appears uniform, with no visible clumps or uncovered areas.
Below the salting zone, the curd enters a large, rotating mixing drum.
As the drum rotates, salt adheres to the surface of the curd pieces. Excess salt falls away and is collected below.
The factory floor beneath the conveyors remains clear, with stainless steel guards and drainage channels managing stray salt and whey residue.
After salting, the curd pieces exit the mixing drums and collect into large, evenly mixed piles on downstream conveyors.
The curd now appears slightly firmer and drier than before, indicating that salting has begun stabilizing texture and flavor.
As curd accumulates inside the molds, the pieces settle naturally, forming a dense mass.
Each press unit contains multiple vertical pressing columns, capable of applying controlled downward force to the molds. The press activates slowly. Pressure is applied gradually, forcing the curd to compress and bind together.
Under pressure, additional whey is expelled from the curd. The liquid flows out through the mold perforations and drains into collection channels below.
The cheese mass inside the molds becomes more uniform as air pockets collapse and curd particles fuse together.
The pressing force increases in stages, following a programmed sequence specific to cheddar cheese production.
We're seeing consistent output from this line now.
Good, let's keep monitoring the temperature.
The factory environment remains stable and controlled, with no manual handling of the curd during pressing.
After the full pressing cycle is complete, the pressure is released slowly to avoid damaging the cheese structure. Residual whey continues to drip briefly from the molds, indicating proper consolidation.
The stage concludes with a panoramic view of the massive molding and pressing hall, showing long rows of press. Each cheddar block is large and heavy, rectangular in shape, and placed individually on the conveyor.
Each cutting machine is equipped with long, straight stainless steel blades designed to slice through dense cheddar cheese blocks cleanly and evenly.
Each cheddar portion is placed into a clear plastic pouch designed for vacuum sealing. The pouch lies flat beneath the cheese with no folds trapped underneath.
The open end of each pouch is aligned precisely with the vacuum sealing bar. Air is removed from the pouch in a controlled manner. As air is evacuated, the plastic